Okay, so today we are going to be working with one where we're going to set up inequalities to help us problem solve. And we've already done, some of that within both of these lessons, but we're going to, take it, and practice it some more. How successful were you with the word problems that you've had, the problem-solving ones you've had so far? How have they gone? I'm seeing you shake your head not so well. How many would agree with that? They didn't go quite as well as the rest of you don't have any idea? Or they went well? They kind of went well. Okay. Well, one of the things that I find when I'm trying to work with word problems and I'm trying to, use, I have to set up my own equation, my own inequality, whatever it is. I write down as much information as I possibly can to set myself up for success. So that's what we're going to do here today. So we have this first one. It says to rent a certain vehicle, Rent a Ride, that's the name of the company, charges $55 per day with unlimited miles. Okay? And then the cost of renting a similar vehicle at We Got Wheels is $38 per day plus 20 cents per mile. So it kind of sounds like they definitely have different costs. So is it kind of like, can we say it doesn't matter which one we rent from? What do you think? What do you think is going to be the determining factor for you if you're going to rent a vehicle from one of these two places? What do you think would be one thing that would be kind of helpful to know?
How many miles you're going?
How many miles you're going to use it for? Yeah, so if one of them has unlimited miles, in other words, they're not going to charge you anything for, you can put 100 miles on it, you can put 1,000 miles on it, doesn't matter. And the other one charges less to start with, but they charge so much per mile. So it's going to be kind of important that we know how many miles we're going to put on it to help make a decision which one we should go with. So for what number of miles is the cost of Rent a Ride less than the cost of We Got Wheels? In other words, when you have unlimited miles, when is it actually less than to rent from them? So let's call our unknown X. So I want you always to identify your variable. What's your variable in your inequality standing in for? So X is going to represent the what? Number of miles. That thing that can change. And we're dealing with, the cost of renting from one company or another. So let's first determine what would represent the cost for renting from Rent a Ride. What kind of an expression could we set up that would help us find the cost for Rent a Ride based on X number of miles? What would it be? What expression could we use? How about this? That's all they're in charges, aren't they? $55. Okay, so 55 is going to be the cost from Rent a Ride. And we're just doing this on a one-day basis. It says per day. It doesn't say anything about that we have to find it for using the vehicle for 7 days or something. So we're just going to assume they want it for 1 day. Okay, what expression could we use to represent the cost from the other company called We Got Wheels?
38 plus 0.2x.
38 plus the 20 cents per mile. And we can leave this 0 off of here. We don't really need that, right? But it's showing that we're actually doing 20 cents per mile. So, and that is our cost from We Got Wheels. And again, the reason I always take the time to do this is because then when I look back and see, when I get it wrong, then I can look back and say, well, how was my setup? Where did I get all this stuff from? Okay, well then, what's the real thing that we have to solve for? When is the cost of Rent a Ride? So the real question here is this question. Rent a Ride is less than We Got Wheels. Yeah, do hyphens in them. When is Rent a Ride less than We Got Wheels? Well, now all we have to do is put our mathematical expressions in place of the words. So rent-a-ride is 55. We got wheels is 38 plus 0.2x. And now we can solve it. So go ahead and solve that. See what you end up with for x. Anybody want to disagree? They don't think we have a good setup, first of all? Should we change our setup? Do you think it's okay? Or are you going to roll over to solving it? You're going to go with it? Okay. Or are you going to wait and see what you give for an answer and see how reasonable it is? Okay, anybody want to agree, disagree with me? What, you get the same solution? Yeah, okay, thumbs up on that one. Okay, well then let's answer our question now in a sentence. What was the question again?
For what number of miles is the cost of rent-a-ride less than the cost of League on Wheels?
Okay, so we would say what?
85 miles.
Well, what does this really say? Not 85 miles.
86 and above.
Yeah, so when it's greater than, so what, let's go over here and write a sentence for this. When you drive more than 85 miles, and by the way, they'll charge you, I mean, you can put on 85 and 1/10 of a mile. It doesn't have to be exactly 86 miles. So when you drive more than 85 miles, the cost, let's be complete, the cost for rent-a-ride is less. Because that's what we were looking for. When is the cost for rent-a-ride less than it is for We Got Wheels? Well, if you plan on putting on more than 85 miles, go with rent-a-ride, right? If you plan on putting on less than 85 miles or even 85 miles, then go with We Got Wheels, the one that charges you per mile. Okay. And it probably makes sense to think, you know, when you have unlimited miles, at a certain point, when as the miles are going up, we would want to go, it would turn out like this, that the rent-a-ride that has unlimited miles would turn out to be less. Okay. Questions at all? Okay, now I want you to try to put enough information down, just like we just did. I want you to do the same thing with this one. I want you to describe in this one we don't have to describe our variable because it's already in there, so we don't really know what x is. It's kind of just in part of an expression, so we don't need to describe our variable. But I want you to write down, like, what's the question, what is it that we have to find in words, and then I want you to put a mathematical statement, or expression, I should say, in that will replace those words. By the way, again, how do we find the area of a triangle?
Length times width times 1/2.
Okay, so it's a half of that, and instead of length and width in a triangle, we call it what?
Base.
Base and height, yeah. So the area of a triangle is found by taking 1/2 of the base times the height. So what is it we're finding in this one in words? I don't want your mathematical inequality yet. I want in words. What are we looking for? We're looking for the height of the triangle, okay. But what else there's some other conditions. What are the conditions? We want the maximum height when what? What do we want the area to be, Todd?
Under 76 inches.
under 76 inches. So that's kind of an important thing to write down. Area is less than 76 inches squared. Area is less than 76 inches squared. And so when we're looking for what's the maximum height we can have if the area is going to be less than that. Okay? So area, well, we said area is found by taking 1/2 the base times the height, so let's just put that in place of area, is less than 76. Well, do we know either of those pieces? Do we know the base or the height? Which one do we know? The base is 8 inches. Okay, do we know the height?
3x plus 1.
Yeah, remember they already described it for us, that's why we didn't have to pick a variable for it. So 1/2 times 8 times, in parentheses, 3x plus 1 is less than 76. Well, it's kind of a nice order. We don't even have to rearrange the order on the left side because remember, we can multiply in any order we want, but it's nice to take half of 8. What is half of 8? 4. Okay, so we'll have 4, and times our 3x plus 1 is less than 76. Don't get too carried away here, because I'm going to show you something that you're going to be like, oh, I don't want to have to work any harder than I need to. We want to know what the maximum height of the triangle, okay? And remember, which one of these is height? 3x plus 1. Okay, so the whole expression is representing the height, not just the x. The whole expression 3x plus 1 is representing the height. So what would be, instead of doing distributive property here, I'm going to suggest we get rid of that 4. How do you think we could get rid of that 4 not using distributive property? Divide both sides by 4. Okay, so we'll just take both sides, and instead of distributing that 4, let's just divide both sides by it, because now the 4s will divide out, they'll cancel out, and we're going to have 3x plus 1 is less than what? 19. What's this again? What's this 3x plus 1? The height. So isn't that right now saying the height needs to be less than 19? The height needs to be less than 19 for the area to be no more than 76 inches squared. There's no reason to take this any further. It didn't say what's the maximum value x can be. It said what is the maximum value the height can be. So we're going to stop right there because that represents our height, and we're going to say the height of the triangle must be what? 19 what?
Inches.
Inches. It was measured in inches, wasn't it? Must be less than 19 inches. So can the height even be 19 inches? Is that the maximum height? No. But could we ever really name the exact maximum height it could be? Could you have 18 and 999 thousandths inches? Could you have 18 and 9,999 10,000 inches? I mean, we can't even really name the maximum height. All we can say is it better just be what?
Less than 19.
Under 19. That's as high as it can get. It can't get to 19, but it can get really close to 19, and the area will still be less than 76 inches squared. Okay, so any questions about it? Okay, let's go to the back side. It's kind of a tricky one, and because Please bear with me, this recording me for a little bit here. We have a race going on, and so we have to use a formula that they don't give us in here. Keith is racing his little sister Patty, and he's given her a 15-foot head start. She runs 5 feet per second, and he's chasing her at 8 feet per second. For how long can Patty stay ahead of her brother? So remember, she gets the head start, but she's running what? Faster or slower? Slower. So she gets a head start. That's why I gave her a head start, because he knows he can run faster than her. So she's already, she gets to go. She's running slower, and they want to know for how long will she stay ahead of her brother, the guy who's chasing her at a faster speed. Okay, so let's put down some information here that, first of all, it says for how long. So we're solving for time, aren't we? What are we given? What are some of the things we do know?
Their pace.
We know the pace. We know the rate that they're running. There's some distance involved there too, isn't there? Doesn't she get a 15-foot head start? Okay, does anybody know the distance formula? Do you know how that goes? In other words, if you want to figure out how far you're going to go, given a speed that you are going at and the amount of time it takes, anybody happen to know what that distance formula is?
Rate over time.
Pardon?
Rate over time.
Rate divided by time gives you the distance? Let's try it.
It's the other way around.
What do you think? Let's just try it. Let's do like Fargo. We're going to Fargo. We're driving, let's say we're teaching somebody how to drive. We don't want to drive too fast on the interstate. So we're letting them go 60 miles an hour. And so they're at 60 miles an hour, and it takes us 1 hour to get there. If we take what did you say you want to do, rate divided by time? And that'll give us distance. 60 divided by 1 is 60, so it's 60 miles. Okay, let's try it. Let's try it with, so distance is equal to rate divided by time. Okay, let's try another rate and time. Let's say you're going the national speed limit, which is 75 miles per hour. Okay, you're going 75 miles per hour, and it takes you 45 minutes to get there. What part of an hour is that? What's 45 minutes? Part of an hour, 3/4 of an hour. Okay, so if we take rate divided by time, would you guys do that for me? Would you take 75 and divide it by 3/4? Rate divided by time, it takes us, we're going 75 miles an hour. It takes us 3/4 of an hour to get there. How far did we go? 100 miles. Do you think that's reasonable? 100 miles to Fargo?
This is a time over rate.
How about time over rate then? Let's try that. 3/4 divided by 75. 1 over 100. So it's only 1/100th of a mile. Not liking this so well, huh? Here's the distance formula. It goes like this. Distance equals rate times time. How fast are you going times how long did it take you to get there? So now, does that seem, let's try 75 times 3/4. Does that seem more reasonable? 75 miles per hour, takes you 3/4 of an hour to get there. Which, by the way, that is about true if we're getting to Fargo. Pretty close, anyway. How many miles? 56.25, yeah. It's pretty close to somewhere between 55 and 60 miles to Fargo, depending on what part you're going to. Okay, so it's rate times time. Okay, well then, we're looking for the time, aren't we? We're not looking for distance, we're not looking for rate, we're looking for time. That's what we're looking for. And the other thing we're looking for is for how long, we're looking for how long will, like Patty, the sister, how long will she stay ahead of her brother? So in other words, isn't that her distance? Isn't, are we going to have to kind of compare it with distance instead? Let's compare it with distance rather than time. So let's look for let's say that Patty's distance needs to be greater than, we want to know for when, how long she's going to stay ahead of her brother, so she's going to have to cover more territory, right? When is Patty's distance greater than, is it Keith? Yeah, Keith's distance. Okay. Well, Patty's distance, remember we get distance by doing rate times time. And so what do you think we can do for Patty's distance? How fast is she running?
5 seconds.
Okay, well, so we have 5 and we'll make that T. 5 times per, 5 miles or feet per second, is it? Was that what it is? Feet per second times how long it takes her to run. Remember, rate times time. So she's running at 5 feet per second times the time. We're looking for time. I guess we should have put that here. T. But remember, this is distance. Didn't she also get some extra distance added in? Remember, she got a head start.
Plus 15.
So plus 15. We got to add in her 15 that she got. She got that head start. So we want to know when her distance, this is distance right here, rate times time, plus some distance that she got for her head start. That has to be greater than Keith's distance. What will Keith's distance be? 8T, yeah, it'll be 8T. His rate times how long he's running. Did he get a head start? Does he have any extra distance? No. Did he move back any? Do we have to subtract anything? No, he just started right from where she started, but she got that extra. Okay, go ahead and solve that. You have an inequality here now that you can solve with variables on both sides. Okay, you get the same solution I do? Same inequality solution? Okay, what's that tell us?
Or 5 seconds.
Okay, so when, it'd be really clear. We want to stop her out really clear. What is that telling us? 5 is greater than T, or if we read it backwards, it'd be T is less than 5. What's that really telling us? I don't want to know what the inequality states. I want to know, how can we answer this question?
Patty can stay ahead of her brother for 5 seconds.
Okay, can she actually, at 5 seconds, what's actually going to happen though?
Tied.
Is he going to be ahead of her? No, they're going to be tied. He's going to be right beside her at 5 seconds, and then after 5 seconds, he's going to move ahead of her, right? So up to 5 seconds, so we're going to have to state it like that. We're going to have to say up to 5 seconds. Patty will be ahead of Keith. There's no equal to bar in there, remember? So up to 5 seconds, but once it hits 5 seconds, he's there, right? They're neck and neck, they're tied. And then after 5 seconds, he's starting to get ahead of her now, isn't he? Okay, so up to 5 seconds, she gets to say she's in the lead. But at 5 seconds, it would be a tie, and after 5 seconds, he would be ahead of her. Okay, so sometimes you have to use you have to use formulas, like we had to use the area triangle formula. Here we have to use the distance formula. Okay, and in the next one, we're going to have to use, it looks like, area of a rectangle and perimeter of a rectangle. So if a rectangle has a length of x plus 2 centimeters and a width of 7 centimeters, for what value of x, notice this time it says for what values of x, this time we are going to have to take it all the way to x, is the area of the rectangle greater than the perimeter? So right here, let's just do this right now. Let's just say area is greater than perimeter. We need to know when the area, values of x for when the area of the rectangle is greater than the perimeter. Well, how do we find the area of a rectangle?
Like these two.
Length times width, or base times height. How do we find the perimeter of a rectangle?
Length plus width times 2.
Yeah, we got 2 lengths and 2 widths that have to be added together to get the distance around. So there's a couple of different ways you could write that. You could say length plus width in parentheses and then a 2 outside, and then have to do the distributive property. Or you could just say we need 2 lengths plus 2 widths. Okay, well, let's just start subbing in what we know then. We know the length of this rectangle is x plus 2. Are these parentheses important?
Yes.
Absolutely. Don't you dare leave them off. And a width of 7. So 2 times x plus 2 on the other side, and 2 times 7 on the other side. So same rectangle, just comparing their area and their perimeter. Okay, go ahead and solve that. You got some simplifying to do first. And this one you have to solve it all the way till you get x alone, because it's not asking for when the length, what values of the length make it. It says what values of actually x. Anybody starts to panic yet? Say, oh no, I don't have nice numbers. Is it okay? What's my last move here? Divide by 5. So when I divide by 5, is this one of those times that when I divide by 5 I get a nice decimal?
No.
4/5.
Yeah, 1.3.
Yeah, what is it?
0.8.
0.8. This time it's a nice decimal, and so we can change it to a decimal if we want, or we can leave it as a fraction, 4/5. Okay. So now we know that when x is greater, this says x is greater than 0 and 8/10. What was the question again? We were supposed to find what values of x is the area of the rectangle greater than the perimeter. So what are we going to say? What's our sentence? When x is
Greater than 4/5.
okay, when x is greater than 0 and 8/10 or 4/5, but then we have to put a label on that. 0 and 8/10 what? What's this measured in? Did it ever say? What is it?
Centimeters.
Centimeters. When x is greater than 0 and 8/10 centimeters or 4/5 of a centimeter, the what? The rectangle will do cartwheels. Yeah? What will make it do flips then? Okay, what's the rest of our sentence here?
The area of the rectangle is greater.
The area of the rectangle is greater than the perimeter. Okay, critical thinking question for you on this. Why would it never matter that the area was greater than the perimeter of a rectangle? in real life. Why would it ever matter? I mean, are we just doing this because they just love to, throw word problems at us and see if we can tackle them and accomplish something and get a right answer? Can you think of any time it would be useful to know what values of X would make the area of a rectangle greater than its perimeter? Jacob?
Maybe if you were an architect and you were building a building or something,
Okay.
you want to know those stats or something.
Okay, so if you're an architect and you're building a building, maybe you'd want to know when are you going to get more area versus distance around. And if you have pets, yeah. And if you have fenced-in yards, yeah. Okay. And do any of you? I bet none of you have ever had to pay for the fence, though, right? No. But it's kind of nice that your pet has as much room to run around as possible, right? Isn't that what area is? So if you can spend less money on the fencing than the perimeter around it, and give the pet that you have more area to run in, wouldn't that seem like a good thing to do? So spend less on the perimeter, the fence, length of fence that you got, because you usually pay for it by the running foot. And so how much money you have to pay for that fence versus how much, space that, your dog, whatever, is going to have to run around in, then it would be useful. So, okay,